New,
bonds, sir.
The
new
chemical
topic we are
bonding.
planning to start, right?
Types of bonds start.
So you
Mm.
have actually said that you're going to start chemical bonding.
Yes, yes. Okay, that topic one I'm going to start to now. Okay. Mm.
Sir, this chemical bonding means that ionic bonds, covalent bonds, that only, no, sir?
Yes, yes. No.
Okay, sir.
One second. Just let me share my screen. Okay. Can you see my screen? Acha.
No, sir.
Okay, na?
Yes, sir.
Mm. Next one. So, topic is chemical bonding. Okay, chemical bonding. So, generally, so why bonds are going to form? First point is why bonds are going to form. That is the first question. Anybody can tell me why bonds are going to form?
Sir, realism.
Hello?
Sir, when electrons are exchanged, bonds are formed.
What is the need
Sir,
of
to get
exchanging?
stability.
Yes, very good. Okay. Generally, atoms are combining or bonds are going to form. Okay. To complete stability. Okay. Mainly what we can say, uh, atoms are combined. Atoms are combined. Atoms are combines. Atoms combines. Or simply we can write like uh, chemical bonds are formed between atoms are formed to attain stability. To attain stability, this topic is first. This part is going to form. Okay, na? Now in this one, first point is we are having. So why the atoms are going to combine? On which basis we are going to have uh, stability? Okay. For that one, there are so many attempts or so many models were there. So out of that, okay, the first and the best uh, attempt was Louis Coselle's approach. Okay, the first part is what Louis and Coselle's approach. Okay, Louis and Coselle's approach. So what is Louis and Coselle's approach? Okay, so they have observed. Okay, they have observed inert gases. They have observed. Okay, for example, when we are observing electronic configuration of inert gases, so how many atoms are there? Electronic configuration helium atomic number 2 and number of electrons are 2, right?
Yes, sir.
And in case of neon, 2 and 8.
Tens.
Argon, it will be 2 and 8 and 8. That means simply the number of electrons in the valence shell. As you know, no, this model. Okay. So instead of that, let us write on our regular method of electron conf. So it will get easy for you, no? So it will be helium configuration is 1s2, right? And neon will be 1s2, 2s2, 2p6. And argon will be 1s2, 2s2, 2p6, 3s2, 3pa6. Next, helium, neon, argon, krypton. What is krypton electron configuration? It will be, so atomic number 2, its atomic number 10, its atomic number 18, its atomic number 36. And next, krypton, no, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6. Actually, after 4s, we should write 3d. But as for my convenience, I am writing here. Okay, na? Xenon, atomic number 54. So what is the configuration will be 1s2, 2s2, 2p6, 3s2, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14, 5s2, 5p6.
Sir, after for what is it, sir? XE.
XE xenon.
Okay, sir.
8, 8, 18, 8, 18, 32. Xenon, no? I think 4f14 it will not come, no? It will become 5s2, 5p6. అది 12, 18, 28, 30, 36, 46, 48. Right. Next one, radon 86. Configuration will be what? 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4d10, 4f14. After 4d, how much will come? 8, 28, 32, 5s2, 5p6, 5d10, 6s to 6p6. So if you are observing valence electronic configuration, how many electrons are there here? 2 electrons. So valence means last shell, right?
Yes, sir.
So in this one, how many
Yes,
electrons are there in
sir.
the valence shell? 8,
Yes, sir.
no? Right? And in this, 8 again. And
Eight.
this,
Sir, 8, sir.
8.
Eight.
Sir, 8,
In
sir.
this, 8.
Sir,
In
8.
this, 8. So, and we know inert gases are more stable, no?
Yes.
Right?
Sir, but helium is two only, na, sir.
That only, no, I said no, except helium. Let me complete my statement. That means what we can say. So in inert gases, inert gases, helium valence electrons are 2. That we can say as a duplet configuration. We can say duplet. Next one, remaining elements. Nana back look at the remaining elements.
It is duplet.
Valence. Which one? Duplet means 2 electrons.
Okay, sir.
valence electrons are 8. That is octet configuration. Octet. Octet configuration. So, as inert gases, it was observed that what we can say. So, inert gases are stable
So because the or
because
suburb
of
are completely filled.
duplet or octet configuration.
Sir, octet
Duplet
is
or
OCTECT or OCTET, sir?
hello,
Sir, octet spellings, what is it, sir?
OCT TET nana.
Sir, you wrote in second line you wrote OCTET, sir.
OCT not CT.
Sir, then down you wrote OCTECT.
Where nana?
Duplet or
Okay,
OCTECT.
OCT ET వచ్చేసి okay, okay, here.
I did not understand which is right spelling, sir.
Okay, okay. OCT ET is octet is correct. Octet to configuration. Okay. So that's why. So by taking this one, so atoms also. This is according to history. Atoms also combine to have octet or duplet in valence shell. Okay, this is the reason why they had given. Okay. Mm.
Sir, could you say how to pronounce the theory name, sir?
Which one?
This theory.
Lewis and
Okay,
Cossel
sir.
approach. Okay, Lewis and Cossel approach. Done.
Sir,
Tell me, Nana.
so in that case, stable also because the suborbital is completely filled also, right?
Which one?
Sir, inert gases.
Inert gases.
So the last suborbital is completely filled, right?
Suborbitals.
Yes, sir. So like 4p6 and you rotate, sir.
Yes.
So in that the suborbital is completely filled with electrons, right?
Yes.
So that's why they are stable.
No. Yes. That also you can say.
Okay, sir.
Sir, what are inert gases?
Okay. Inert gases means helium, neon, argon, krypton, xenon are there, no?
Okay, sir.
So these gases are doesn't react with any other elements in normal conditions.
Okay, sir.
Okay.
Sir,
Uh, these gases only can called as inert gases are noble gases also we can call.
Sir, what
Okay, na?
is octet configuration?
Octet means who is asking here?
Ritvik, sir.
Octet means in its valency having 8 electrons.
8 electrons, sir.
8 electrons in the valence shell. Now see, as they are having, see, these are valence shell means what? Last shell, no?
Yes, sir.
Last shell having 8 electrons, so that's why these atoms are get stable.
Okay, sir.
sir,
Mm.
so can we say that two reasons for most stable are octet and duplet configuration and completely and half filled orbitals, sir?
Yes, that also you can say.
Okay,
Okay.
sir.
The
Uh,
octet configuration is fully filled, then only it is octet configuration, sir.
Actually, how they are comparing, no? First, let me finish first what I want to say. Then you raise your doubts. Okay. First, actually, atoms are going to combine. So it was given that one, why the atoms are going to combine. That was the question raised in the scientist. Okay. Then what they said, so combined means they are reacting each other, right? Whereas coming into inert gases are not reacting with any other compounds among themselves as well as any other compounds also. So then they have taken inert gases configuration they have observed. Okay, so that now they came to know that so atoms inert means it will not react with any compound. Inert meaning that only na. So now they understood, okay, these are inert because in its valence shell there are 8 electrons in the shell or 2 electrons. Okay, now if I'm taking, see, so everywhere if I'm taking no 2s to 2p6, 5s to 5p6 only there, this only we are saying that inert shell, right? In the valency shell we are having 8 electrons only. Likewise, valency means lost shell, right?
Yes, sir.
Mm. So in the valency shell, so as they are having either 8 electrons or duplet electrons, so the atoms are not reacting with this any compound. That means they are stable enough. So that's the, by taking this as a reference, they are saying that atoms are combining, combining, okay, only to have 8 electrons are duplet configuration in the valence shell. If 8 electrons are duplet configuration is there in the valence shell, then the atom is stable. Just they are doing comparison. Okay. Now ask me what you want to ask. Ask me now,
Sir,
any doubts you can ask me.
sir,
Tell me.
sir,
Tell me.
sir. If the valency is having 8 electrons, it is a octet configuration, sir.
Yes.
Okay, sir.
Okay. Hmm. So this is what thing. And one more thing, he said how we are going to represent the periodic, how we can represent the atoms. Okay, how we can represent the atoms also they had given. How they can represent the atoms that also given. See, let me this. Generally, Lewis representation for writing. దాంట్లో కొద్దిగా ఉంది కదా. Okay. Now, Lewis symbols are how we will write these Lewis symbols. We are going to write the representing electrons, representing valence electrons. Okay, how we will write? Hmm. So representing valence electrons. So how it will be there? Channam. So how we are going to write? For example, we can use either cross or dots. We can use for the writing the electrons. Okay. Valence according to this valence electrons can be represented as dot like this or cross. You can use any one of this also. Okay. Simply we can write like this. For example, uh, in case of lithium, how many valence electrons are there in lithium?
Sir, one.
Sir, once can you go to the previous slide?
Sir, one, sir.
1 second, Nana. Let's complete. Somebody is writing this now. Let's complete this, then we can go.
Yes, sir. Done, sir.
Mm. How many electrons are there lithium? So that one electron. So you will write
One.
only one mole.
One, sir.
And in case of beryllium, how many electrons are there?
Sir, two.
Two, sir.
So two electrons. You can write these two electrons anywhere also. It's up to you. Okay.
Okay, sir.
And carbon, how many electrons are there?
Sir, two, sir. Sir,
Carbon valence electrons.
six, sir.
Four, sir.
Four, no?
Sir,
Four,
four.
sir.
These four. And nitrogen?
Five.
Sir, five.
Five. Okay, na? What about neon? Neon, how many electrons? Eight, no?
Eight,
Eight.
sir.
I told you, we can represent either with cross or either with
Sir, dot.
dot. So this is the way you are
Sir,
going to.
electrons, no, sir.
Hello?
Sir,
Uh,
neon has 10 electrons, no, sir.
Nana, valence electrons we are writing, no? Valence electrons. Neon having 8
Okay.
electrons in the valence shell. Total electrons are 10. We have written configuration, no? Just now. 1s2, 2s2, 2p6. Valence shell means lost shell. Okay, na?
Okay, sir.
So that is chemical bond, right? Now understood bond and how electrons we are going to represent. Next,
Yes, sir.
next concept is types of chemical bond. Generally, we are having three types of chemical bonds. We are having basically. Okay, that is what we can say: electrovalent,
Covalent, coordinate.
electrovalent is also called as ionic bond.
Electrocore.
Next one, covalent bond. It's also called. Okay, so next one is covalent bond. Next one, coordinate covalent bond. Which is also called as a dative bond. Okay. Now, for these atoms, we need to discuss. Okay, Nana? Hello.
Yes, sir.
Next one, we are going to
Sir.
ionic bond. So, what is ionic bond? How it is going to form? We are going to discuss now.
Sir, in periodic table and its properties, you told some double bond and metallic bond. Those all come under these bonds, sir.
Yes, yes.
Okay, sir.
Sir, once can you pronounce the name for coordinate covalent bond?
Coordinate covalent bond.
The bracket one, sir.
Dative, DATIVA, dative bond.
Yes, sir.
First bond is ionic bond. Okay, ionic bond. Okay, so ionic bond is formed, okay, by complete transfer of electrons from metal to non-metal to complete or to acquire 8 electrons or 2 electrons in its outermost shell. So ionic bond means what we can say. This bond formed by this bond. This is B. Okay, na? This bond is formed by complete transfer of electrons from metal to non-metal. Okay, or we can say this is non-metal to acquire 8 electrons or 2 electrons in its outermost shell in the valence shell. That means what we can say, from metal to straight away non-metal, it is going to transfer the electrons. Okay, or we can say, or we can define one more also. Okay, ionic bond, it is Coulombic forces of attraction.
Sir, can you go to the previous one?
One second. Coulombic forces of attraction. Coulombic force of attraction between cation and anion.
Done, sir.
Mm. That means cation is positively charged ion. Hello?
Yes, sir.
And anion is what?
Sir, negatively charged ion.
So between positive ion and negative ion, what we can say?
Attraction, sir.
Attraction will be there. No, that attraction we are saying that Coulombic force of attraction, and this Coulombic forces only attraction is called as a electrovalent bond. We can say. Okay, na? Yes. For this one, example what we can say,
NaCl.
KCl, NaCl, MgCl2. Okay, these are going to form. So how this is going to form? RCAF2, MgBr2. These are all ionic bond examples only. Okay, how it is going to form? Okay, so how it is going to form? Okay, how it is going to form, that we are going to see. Mm. For uh, example, let me take a formation of NaCl. Okay, formation of NaCl. Done.
Yes, sir.
Uh,
Sir, always they'll form eight electron or two electrons only.
yes, yes.
Okay, sir. Eight electrons or two electrons in metal or non-metal, sir?
Anything in any case.
Both are ionic only, sir, even in both
Yes,
cases.
yes.
Okay, sir.
Okay. So how it is going to form? Uh, how it is going to form? Let's see. Example I'm taking formation of NaCl I'm taking. So NaCl how it will form basically? It will form by Na plus ion.
Cl minus.
This is Na plus, and one more Cl minus will be there. So between these two, there will be attractions will be there. Because that interaction only we are saying that. So how Na plus and how it will form? See that. Uh, what is sodium electronic configuration? 11, right? So that will be 1s2, 2s2, 2p6, 3s1.
3s1, sir.
If I am forming sodium, if it is forming one electron, losing it is 10 electrons, it will become. What is that?
1s2, 2s2, 2p6, 3s2.
3s2. Done no? Na plus means what? One electrons is removed,
Sorry,
right?
sir. Sorry.
Yes, sir.
So how many electrons are there in the
Eight.
after removing?
Sir, 10.
8 electrons in the valency. That means what? Sodium, by losing one electron, it will form 8 electrons in the valency shell, so that Na plus ion is stable,
That electron is
isn't it?
transferred to chlorine, sir.
Yes, that electron is going to, because say when one atom is losing electron, so some other atom must require no to gain electron. So why chlorine only gaining? I will tell you.
Chlorine is 17, sir.
Chlorine is what? 17, right? That is what? 1s2, 2s2,
Two,
2p6,
three.
So 3s2.
3s2, and 3p5. So how many electrons are there? There are 7 electrons. So by gaining electron from sodium, it will form Cl minus. That is 80 electrons. That means what? 1s2.
1s2, 2s2, 2p6, 3s2, 3p6.
3s2, 3p6.
Very good. 3s2, 3p6. That means what we can say, by
Sir, 8.
gaining also, it is also getting benefited. By losing, it is also getting benefited, right? By having 88 electrons. Now what will happen? These two ions, because individual ions, there is no existence, right?
Yes, sir.
So that
Plus
means
and
what we
minus
can write?
individuals.
So that it will form as Na plus ions and Cl minus ions comes together. Okay?
It will be neutral, no, sir?
Yes. Understood, Nana, what I'm trying to say?
Yes, sir.
For example, let me take one more example I will take. MgBr2 or MgCl2, let me take. Because chlorine bromine comes under same group only, same electrons only, difference is the that one. And magnesium, what is atomic number?
So 12.
12.
Configuration is?
So 1s2, 2s2,
2p6,
2p6, 3s2.
2s2.
Hmm. Now here, if it is forming two electrons, by losing two electrons,
It will
So 10.
so by losing two electrons, what it
8
will become? It will
electrons in
become
the valence shell.
So 2p6.
P6. So 8 electrons in valence shell.
Chlorine will gain that electron.
Now what we can say, there are two chlorine atoms, right?
Yes.
Yes or no?
Yes.
So one chlorine having 17 electrons. So that
So
will, it
3.
will have
Okay.
1s2, 2s2, 2p6, 3s2, 3p5, and Cl minus will be what? 18 electrons it will become. So it will be 1s2, 2s2, 2p6, 3s2, 3p6. So one chlorine having 8 electrons like this. That means, okay, 8 electrons in valence. Now what we can say here, Mg plus 2 ion is there. This will attract to two chlorine atoms. Cl minus here, and here also Cl minus. Okay. So now see, individually magnesium also getting 8 electrons in the valence shell and
So both the chlorine are getting 8
getting
each.
8 electrons in the valence shell. That means what we can say, both we can say it is, what we can say, both we can say it is
Neutral.
neutral,
Yes,
no?
sir. Sir, so number of an atom
Understood,
also
Nana? What did
has
I say?
dependence or inference, sir. Number of
Hmm?
an atom also depends on this ionic bond, sir. Okay,
Yes.
sir.
Okay. Now see, here one point is there for objective purpose. So as we are saying that ionic bond is like interactions, isn't it? Interactions means what we can say. Interactions means what we can say, Nana. So attractions, no. So that attractions can be in any direction, right?
Yes.
Yes,
So
sir.
it can be X, Y, Z direction, any direction or
Yes, sir.
not.
Yes, sir.
So that's why what we can say clearly. Hello.
Yes, sir.
So clearly what we can say simply, this ionic bond is non-directional in nature. Okay, right? Non-directional in nature, because see, that attraction can be in any direction, right?
Yes,
Yes, sir.
So that's why we can say this. Mm. And coming into what we can say,
Sir, are you writing anything?
nothing, Nana. Just I'm doing this.
Sir,
Yes.
Tell me, Nana.
sir, for Mg2, you wrote 2p6 and 3s2, sir. So at the end, so then it will be 8 electrons only, right?
Uh,
Sir, for Mg equals to 12, you wrote 1s2, 2s2, 2p6, 3s2. So,
uh,
sir, 2p6 and 3s2 will have 8 electrons, right, sir, in valence?
but actually, valence shell is what here? Three, no.
3s.
Yes, sir.
So valence shell means what? Lost shell, right?
Yes, sir.
Lost shell. So lost shell is third shell, no?
Yes, sir.
Hmm.
Okay, sir.
In last
Then
only two are there.
like lost shell, we are having only
Sir,
this, no?
even if two are there also it's stable only, no, sir.
What?
Even if duplet configuration is there, then also it's stable only, no, sir. Then why
Yes.
magnesium should transfer, sir?
Uh, Actually, what we can should know, magnesium, which is very nearer to inert gas configuration, no? That is neon configuration, no?
Yes, sir.
So inert gas means what? Magnesium near inert gas, what? Magnesium nearby inert gas, which one we are having? Neon only, no?
Sir,
Neon, sir.
neon, sir, neon.
That's why. Okay, na? Whereas the two electrons we are going to observe only one electron systems only we are going to observe that.
Okay, sir. Like helium, hydrogen,
Yes.
and
Okay.
positive and negative
Yes.
atoms. Okay,
Next
sir.
one is, so what are the factors which uh, govern the formation of ionic bond? Okay, that means what? What are the, because see how easily it will form ionic bond. Huh? So that depends on what? How easily it will form, how easily it will form cation, and how easily it will form anion, isn't it? Hello.
Yes,
Yes, sir.
This is what we can say about the cation and anion. We can find out generally uh, factors governing the formation of ionic bond. Okay, first one, factors for cations. What are the factors for cation? We can say, tell me first one. Low ionization potential, low ionization potential, and low electronegativity. Okay, low electronegativity. That means the atoms which are going to have, and what we can say, low IP value will be highest size.
Sir, that means if these factors are there, cations are formed, sir.
Cations can form
Okay.
easily. Okay. Next one, factors for anion.
Sir, what is the second point you wrote?
Electronegativity. ठीक है. What we can say, highest electron affinity, and small size of atom, and okay. So this is what we can say. These two parameters will affect the formation of cation. So if greater the formation of cation and anion, no, so greater is the formation of ionic bond. Understood?
Sir,
1 second.
Sir, electron affinity means what, sir?
The amount of energy released when one electron is added. Okay, greater the formation of cation and anion, greater the uh, formation of
Bond.
ionic bond. Okay.
sir,
Mm.
sir, what about ionization potential for anion?
IP value should be maximum. It will be there, no? Because if it is okay, hello, ionization potential of anion. If I'm taking, no, if anion having highest ionization potential, then it will form A minus, no. It will lose, no.
Yes, sir.
IP value for removal of electrons, right?
Yes, sir.
Sir,
Okay.
sir, can we say for anion, high electronegativity is required? Because if we give an electron, it can absorb easily.
Yes.
Okay, sir.
Mm. Okay, Nana, have you understood what are the conditions for that?
Yes.
Yes, sir.
Okay.
Sir, I have a doubt.
Tell me, Nana.
Sir, once can you go to the previous slide? Yes, sir. Sir, in this After Mg plus 2, we got 1s2, 2s2, 2p6, no sir.
Huh?
It is the same electronic configuration for neon, no sir.
Yes.
But the both elements are different, so they should have that means different configuration, no sir.
It is ion, right? Ions can have same configuration. Atoms will have different configuration. Okay.
What
You
is
are
the difference
comparing
between
one
atom
atom
and an
and
ion?
an ion. You are comparing. Okay, na?
Okay, sir.
Sir, I have doubt related to electronic configuration once.
Tell me.
Sir, in isotopes, the electronic configuration will be the same, right?
Which one?
Sir, in isotopes.
Isotopes. Okay.
So it will be the same or different?
Isotopes. At isotopes means what? Having same number of atoms, right?
Yes, sir.
Same number of electrons.
Okay, sir. So it will be different in isobars, right?
Yes.
Okay, sir.
Okay, students. Then. Good night, all of you.
Thank you, sir. Bye, sir. Good night, sir.
Okay, sir.
Thank you, sir. Bye, sir. Good night.